I'm really appreciating whoever took time and got to connect with us today. Also, hi to all, good evening, good afternoon, good morning, wherever from we are joining. Now, just before we start with the Pranay's presentation, just brief about CODEC community. So few of us in various communities from various companies, we decided like we should have some kind of community for the public people who are from technology background. So these could be anyone which are working as a software engineer or as a business analytics or as a product manager or cloud computer, cloud manager, cloud developer. All those kind of people who are related to technology could be part of this codec community, and we would like looking for more people to join, so you can uh, reach out to more people to join this community. And if you have any ideas or if you want to host anything, you can reach out to us and we can schedule something for you guys. We also have ideas for open source projects in upcoming uh, future. And if you have also some ideas for for some open source project or something you want to host or want to present, then let us know. That will be great, and we are really looking forward to that. So this was something little bit about the codec community. Now I just want to ask you people, are you able to see the screen? Just any one of you can say yes.
Yeah. Yeah.
Cool. Now, second thing, I would like you to please switch on your cameras if possible, because it will be great to see our audience and it will be good for the speaker as well to know their audience while talking. So I'll just request that, and we will take Q&A after the session. So if you have any questions, you can put in the chat and we will cover in the end, or in the last, you can unmute yourself and ask the question directly to Pranay. Now, before I give it to Pranay, just small intro about myself because I am speaking for so long. So I'll just introduce myself. So my name is Khushbu, and I've been working with Cimpress from past 3.5 years. Currently, I'm a lead software engineer here. And yeah, and mostly I was started as a software engineer and then I grew and became lead software engineer. So this is a little bit about me. Now, speaking about our speaker, Pranay. So Pranay has experience of 17 years and he's been working for 4 years in cloud developer domain. So he will be talking with us about cloud developer and how to develop applications in the cloud. So over to you, Pranay, now.
Okay. Thanks, Khushbu, for introduction, and thanks for giving me an opportunity to talk about this session. Uh, let's hope I will try to make this session more interesting and knowledgeful. Let me share my screen. Good evening, good afternoon, everyone. So, why I'm talking about this cloud developer? Probably you guys have never heard something called as a cloud developer, right? Okay. By the end of this session, probably I will be able to explain you what exactly I mean by the word cloud developer. Okay. If you guys have a different opinion about that, we can definitely have a discussion on this part. Okay. But that is my view. Let's see about it. So about myself, as Khushbu mentioned, that I have around 17 years of experience total, which includes working on various domains from investment bank, finance, insurance, manufacturing, lot of domains. I have seen a lot of different development ways of we develop softwares. Okay, from monolith applications to web services to kind of different kind of web services, to the REST web services, to the microservice world, to in the API world. So a lot of different architectural pattern I have seen. Okay, we have been changing a lot of our ways of developing things. Now we see the new way of developing where we use cloud a lot. Okay, and that's the reason I'm talking about this. And what are the things that we should be aware of? We will talk about this. Okay, so I wanted to set an expectation about this presentation before, because if you want to think that, okay, Pranay is going to talk about some lot of fancy thing and other things. So let me set an Okay, what exactly you will be expecting from this course. Okay, I'm going to talk about how the world has changed from normal way of development from the last 20 years or something till now. Okay, what technology evolution has taken place, why it has taken place. Okay, and how we as a developer have to change. Okay, how we were developing softwares earlier, how we will be developing softwares now, and probably how we will be developing softwares in future. Okay, and while developing the softwares, what are the things that we will require? Okay, that is what I'm going to talk about. So if you see, I have mentioned something called the challenges with cloud and microservices. Then what do you need to do before you start developing applications? Okay, then in the development phase, what are the things that you should know about it? Okay, after development, you want to ensure that your applications are running. Okay, you have to ensure that there is a run the business should not affect. When the business will be not affected, when your applications are running. But we all know that that is not true. Applications will have problems. Okay, we will have production incidents. We'll have to find bottlenecks in our applications. How do we do that in today's world? Okay, what are the tools that we will be using for? I'm going to talk about all the tools and technologies that we can use that will help us to make our life little bit easy. Okay, so that is what I'm going to talk about in this session. I hope it will be an interesting session and you guys will have a lot of questions which will also make me think. So let's move to the world called software developers. So I believe most of us are software developers, right? We have been developing software, and how do we categorize ourselves as software developers? So if you probably, if there are HR guys, they will say, okay, I want a backend developer. Someone will say, I want a front end developer. Sometimes nowadays we use more extensive word as a full stack developer. Okay, full stack developer, the developer who is going to work on UI part, on also the backend services, right? Some developers can be categorized as a mobile application developers who develop applications for iOS or Android, okay, and some part of some other operating system or something like that, maybe a Windows or Windows mobile phone. But yes, this is how we normally categorize our developers. I take a lot of interviews, right? So when I take interviews, people will talk about, oh, I'm a backend developer. I do not know anything apart from developing services where I develop REST APIs. Okay, so I'd ask them, okay, do you deploy your applications on cloud? No, we have a separate team that we just build an application, we push in our code, and then there is a team that takes care of bundling the application and deploying on the production. Okay, does it in today's world, is that enough for just developing an application? Let's see whether that is enough or we need some more expertise, okay, when we start developing application. So before we move, go into the details of this, let's say, what is a cloud developer? Okay, if you are developing any application that is deployed on anyways on any of the cloud infrastructure, maybe it's an AWS, Google Cloud, Azure, or Cloud Foundry, or L nodes, anywhere on the cloud, okay, then you're developing applications for cloud. Okay, and then you can call yourself as a cloud developer because you might be using some of the cloud things, and that's why I say that we should be a cloud aware. The term that I'm trying to use is a cloud aware, that you are aware of the infrastructure, you are aware of the cloud infrastructure that we'll be using. Okay, so what is the cloud awareness and other things? Let's see. Okay, so traditionally when we started developing, so it's a long back, okay, long back when we have a Windows or a desktop application where people used to build a word processor or custom applications. Okay, so everything was installed as a binary on your application. So software developers will build such kind of application and will be distributed to individuals. They might get CDs or download and run on their desktop. Then came the internet world, where the applications were no more installed on your system, but could be accessed via internet. Okay, that actually changed a lot of things. The way we consume the application, the way service provider build their application. Okay, so how it changed? Okay, we know that. Okay, let's say you consume a YouTube or a Netflix application. Okay, so you are consuming Netflix in India. The same person, there might be people who are consuming somewhere else in the world. Okay, how these applications are scaled so that people can be accessing it from all over the world globally at the same time, no issues with the performance, latency. Okay, how are these things are happening? What is that makes that application so fast? Okay, if we are aware of these things, okay, and we know what are the challenges that might face, then we can overcome that challenges by building some tools and applications, okay, to give our customers what they want. So today's world's application, right? Video streaming, Netflix, YouTube, okay, which are high volume applications, okay, and huge customer base. So we know YouTube, Google, it has millions of customers. WhatsApp, millions of customers. Facebook, millions. Okay, so many customer base we have. Now imagine there is a time when your Netflix is down or YouTube is down. We feel frustrated, right? We say, oh, why it is down? I can't access my content, right? And we want it to be up. So now that's a challenge for the service provider. And indirectly, that's a challenge for us as a developers. Okay, when we write applications and we deploy that applications, that should have a high availability. It should be always up. Okay, how do we achieve that? That's a challenge. That's what we will see. We will try to see that. Okay, then you also want the security of your application. The service provider will say, no, I want, there is a huge data with me. Okay, it should be secure. No user's data should be hacked or it should be compromised or something like that. Okay, so that is also one challenge that we have. Sometimes data compliance, okay, GDPR compliance. Most of us might have taken the training of GDPR, right? What exactly that is, and that is the requirement of today's world application, that you want to have all these things in your list, probably more. I just added some few things, but there might be tons of things that are required in today's world's application. Now talk about the customer base. Okay, so I just spoke a few minutes back. What is the customer base, right? Customers are spread across globe. YouTube is accessed by anywhere. Okay, we can access YouTube content of India. We can access YouTube content of Korea, Japan, US, Europe, Africa. From content that is spread across anywhere, we can watch. Okay, how so the customer base are spread everywhere. Okay, they want to have the local content, they want to have international content, okay, and they want to have content at a much faster rate. And the way we are consuming data is huge. We do not want buffering nowadays. We just want it should play. Okay, so all these things are that the customers are demanding a lot. If now imagine that if your customer, most of the organizations say that, okay, we have a base in USA, we will deploy all our application in USA. Will that work in today's world? May not. Okay, because customers in Europe or Asia will definitely find latency in consuming that application. Okay, then how can we do that? Okay, cloud helps us. So if I'm just a normal service provider and I have my hardware installed in some part of US or in my garage or something like that, okay, with the huge 64 GB or terabytes of memories, and I'm still deploying and running my applications in one place, I have a huge risk. My application can go down, my hardware can go down, a lot of things can happen. My customer base will be limited. Okay, and hence I want to deploy my application not just in one place, but it should be deployed multiple places, multiple regions. Means for US, it might be deployed in US, for European customers in Europe, and Indian customers. Okay. At the same time, compliance also says that, okay, the data should be part. If you are giving data to, if you have user base in India, and that's a financial app, then you should keep your data in India itself. That's the requirement from RBI. Okay, so now if I'm a financial app provider, I have to ensure that the data, the user data, is stored in Indian server itself. It should not go out of the territory. So all these things are there. That are the challenges. Okay, to summarize that, we need a fast and reliable services, fault tolerance, high availability, and it should scale. It should scale in the sense, if there is a high demand of, let's say, people are watching, there's a festival season and people want to enjoy a new movie that has been released on OTT platform, and thousands of millions of people are trying to watch this same movie at the same time. Okay, our application should be able to scale. We know about Hotstar, right? Hotstar is being viewed millions of times when there is a cricket match going on. Okay, how it is consuming? It is scaling its infrastructure on demand, but not necessarily always. Okay, whenever there is a demand, whenever there is a cricket match, when people want to watch live content, okay, they will have to come up with a provision where they can scale their infrastructure. Is this possible with the traditional way of developing application and deploying application? I don't think so. It's so simple to do it, and that's why we need something called as a cloud infrastructure. Okay, there is a provider, service provider, who has their infrastructure spread across globe, and if we can leverage their infrastructure. Okay, and that's why we nowadays we call the term as infrastructure as service. Okay, we have this word and we use that infrastructure depending upon the location or multiple location we deploy our application. So what are the different providers? We have AWS, Azure, Google Cloud, VMware, DigitalOcean, IBM. There are a lot. These are just few. These are some just top service providers, but we have plenty. What do they provide? In the simplest form, they provide computing. They just provide virtual machines. They just provide file storages. They might provide you load balancers. Okay. Now you guys will tell me why am I talking about these things? The reason behind this is that as a developers, you will have to know about these terms, because your application will be affected by the way you will deploy your applications. Okay, how the way you will scale the applications. If you do not have enough information, you can make things really bad. How? We will see in some of the future slides. Also, they just don't provide the computing and everything. They do provide some managed services. Managed services in the sense, we just say, okay, I just want a new Oracle database, okay, or a Postgres database. I want a NoSQL Cassandra database, okay. They will provide you everything with license and other things, backup facilities and lot of things, okay, a completely managed service, okay. So cloud providers, different cloud providers will provide different kind of managed services to you. Now, as I was mentioning, that when we have these cloud providers, we can leverage their infrastructure by deploying application on multiple zones. I just got this snapshot from internet. Okay, so I have not taken that much of pain to draw certain things. I got it from somewhere. But what this diagram says that, okay, we can deploy our application not just in one region, but it can be deployed in multiple regions. Here I'm showing just two regions, in US and European regions. Okay, and they have the completely same stack. At the same time, you can also see that I am trying to sync the data between the different regions. Okay, so that the customers from one region can access data from the other region. Okay, so all these things are happening, and why this is possibility? It's only because of the cloud. Wow. So we talked about cloud, and I know most of you guys are already aware of cloud and other things. You might see, oh, Pranay is just repeating a lot of things that we already know. Yeah, I know most of us will be aware of these things, but I'm trying to create a stage for those who might not know. Okay, so please bear with me. You might see some content which will be definitely useful for you. Okay, Microservices. With the world of cloud infrastructure, people have also started developing their applications architecting their application in a different way. Okay, the term microservices came into picture and it became a buzzword, and people were just trying to develop microservices. Some succeeded, some failed. Okay, I can tell you, Netflix. I am a fan of Netflix, not because of the content that I watch on them, but because of what they have given to us in terms of uh, microservices. Okay, they have a classical examples and lots of tools and lot of applications that they have provided, which had made life really easy for developers. Now, as a developers, we should know what are the things. We should know how to use them. We should leverage them. Okay, so that's the reason I'm a fan of them. I had seen so many things, but you know how much time that Netflix took to become 100% microservices from the traditional monolith applications. It took 7 years for them to migrate all their monolith applications to microservices. Huge pain, huge efforts, lot of failures. Okay, and I think we should learn from them. Okay, not repeat the mistakes what they did. They have come up with tools and services. I'm giving just an example that yeah, Netflix has given. There are so many other things who have done. For me, personal favorite is Netflix. Okay, I have been using. There are a lot of tools which I will be talking about. Okay, and services which we leverage to make my life as a developer a little bit easy. Okay, so we will talk about it, and that's the reason I'm trying to stress about Netflix. With the world of microservices, why did it got famous? Some people like it, some people hate it. We say, okay, so many of services I have to build, okay, I have to maintain them, and a lot of problems. And yes, there are challenges with microservices. There are challenges with monolith. Okay, there are advantages with microservice architecture. Okay, now what is our use case? Depending upon that, we will try to use it. One important thing that microservices got was loosely coupling. Okay, it's loosely coupling. The term is also loose. Okay, if I'm a developer and if I don't know right way of architecturing or developing an application, I write microservices, but still I can make my application as a tightly coupled. Okay, so whenever you're developing application, please ensure it is loosely coupled. Okay, plus each microservices can be easily maintained, can easily be tested, and a lot of things. Okay, again, when I say it can be easily tested, there are challenges. Okay, what are the challenges? We will see. Now, just a small comparison between monolith applications and microservice application. Again, diagram stolen from internet. Please don't say that Pranay has drawn this. No, I have not. I just stole it from internet. Okay, this diagram shows that, okay, I have a monolith application, okay, which is one application that runs in a memory, which might take 4 gigs or 5 gigs or 10 gigs of RAM, okay, and 15 cores of CPU or whatever cores of CPU that it requires, and it runs. Okay, perfectly fine, it runs. Now there is a peak season, holiday season, and then my application needs to be scaled. Oh, what should I do? I add more RAM memory and I do things and all the things. So I'm just trying to vertically scale my application by adding more cores, by adding more CPUs. Okay, is it sustainable? I don't think so. There is a limit by which you can add multiple CPUs and to your existing infrastructure. Okay, and that's where microservices will help you. So microservices can allow you to horizontally scale your application. Let's say there are 10 microservices and there are only 3 microservices which takes huge memory and huge CPU and a lot of processing is done on that. You can scale only those microservices. You can give more CPUs. You can add more and more instances only of those microservices that you require. And one important thing about microservices, remember, never keep a single instance of your microservice. Okay, okay, you should add redundancy. Even though if I have one instance and I say it is sufficient, in test environment it's okay, but in the production you should have at least 2 instances of one microservice running. Okay, because if one of the instance goes down, your entire service does not go down. At least some consumers will not be affected by that, and you would be able to scale, bring another instance up if you have a necessary infrastructure available, or if you have done necessary pre-development thing, that what I mentioned in my agenda, right? If you have done that things, then you would be able to, your system would be able to detect failures and would be able to scale up new instances as and when required. When we talk about loosely coupled, very important thing we have to understand that every microservices that we develop in our applications are independent. They are independently developed by a team, and should be independently tested and should be independently deployed. Okay, so that is very important. Now, these all loosely coupled microservices that you have, they work in such a manner that it provides a service to your client. Okay, and that is what we will see. With microservices world comes end-to-end ownership. So you guys remember that I was talking about, okay, I was taking interview, I talked to people, oh, I'm a backend developer. I develop applications. How do you deploy it? Oh, we have a separate team that deploys it. Okay, we have a separate team that tests the application. I don't do the testing. We just write unit tests. Okay, so that is what people will tell about. I would say no. From now onwards, that's not the case. If you want to become a today's world developer, it becomes end-to-end responsibility. Okay, exactly. End-to-end means even architecturing, designing, developing, unit test case, integration test, deploying, maintaining, scaling, everything has to be taken care by that team. Okay, there are no separate teams for separate things. Okay, then only that's the end-to-end ownership that as a developers we have to build, we have to change the way we develop, change our thinking. No. I'm just a developer. I can write good algorithm, fast applications, and highly scalable applications. No, that's not enough in today's world. In today's world, you have to do everything. You should know how your applications will be built. You should know what infrastructure your applications will be deployed, how it will be deployed, how it will be scaled, what will be the issues. It might have issues with the other microservices that is impacting your microservices. A lot of things will be involved in this. And as a developer, it will be your responsibility to understand that thing. It will be your responsibility to know that thing. It will be your responsibility to support it. So that's the reason end-to-end ownership. When we say ownership, it means responsibility, right? Now, when we say microservices, I mentioned about vertical scaling and horizontal scaling. Microservices will give you horizontal scaling. We'll add multiple instances. We'll add redundancy, like what I was talking about. One important thing, your microservices should be stateless. What do you mean by stateless? Okay, we know about the cookies and other things that we have state management and other things. No, in the world of microservices, it is an API that they communicate. We should make our application stateless, period. Okay, whenever you will develop applications, if your manager says, no, to just maintain a state there, no, then you are doing something wrong. You might not know right now. In future, you will suffer by that. So make your application stateless. That's it. Fault tolerance. Okay, if something goes down, it should be able to come up in some other way. Now, yeah, we talked about microservices. We talked about what it can give, but is it everything the same? The advantages can also be a disadvantage. Okay, because when we have one monolith application, okay, it was easy to test, it was easy to debug. Okay, but now it's not that case. You might have hundreds of microservices running as a one application. Okay, and something can go wrong in any part of that application. Okay, so managing this many services can be really a challenge. Okay, now deploying them can also be a challenge if you do not know right tools and right way of doing it. Scaling them. Okay, all these things are challenges, but there are tools. There are a lot of tools that are already available. We should know how to use them, and if you use it in the right way, then things become simple for you. Okay, and that's what we will be talking about now. With cloud, we have where I'm going to deploy my microservices, which region, which zone I'm going to deploy it. Okay, now I have so many microservices. How I'm going to discover how my applications will know which microservices is where, how can I find it, how can I discover, what is the way? Am I going to ask with the IP addresses? No, IP addresses changes, right? Your application is restarted. Okay, there are multiple instances. Am I going to store multiple IP addresses for each microservices? No. So how do I discover them, my microservices? Okay, how do I route to the microservices? Okay, I need to know that when I want, okay, I say there's an account service. I want to find an account service. Okay, that account service, when I'm calling in one of my microservices, my calling microservice should be able to discover it, find the proper route, and go and reach to that application. That application, as I mentioned, that we should have minimum 2 instances. Okay, so now, which instance should I reach? I should reach this or that, or when? How should I do it? There comes a load balancer that will do the things. Okay, so load balancer will normally do. There are multiple load balancers. Okay, it's again a very vast topic. Load balancers. If I start talking about load balancer, it will take at least half an hour. What are the different load balancers and how do they do it, and lot of things. Okay, so I'm just giving you should know about load balancers. If you need to know, go and find what are the different load balancers that are available. Cache management. Okay, I said we do not have to make stateless applications, but we need to have caches in our applications. Okay, so that we do not hit databases all the time. Okay, so that is also a challenge. Okay, if I have multiple instances, let's say 4 or 5 instances of one service, and that service needs to cache data, am I going to cache the data in all the microservices? Okay, so again, bad idea. So what is the good idea about it? Let's see if we get enough time, we can talk about it. Security. Okay, security is very critical, because if you have too many services and too many things that people can talk about, then there are multiple ways to enter your system. And if there are multiple ways to enter your system, you always have to worry about the security. Okay, you will always have to worry about your security, and that's where, in terms of microservices, security also becomes very vital. Wow, what do you see here? A mesh of services. Okay, again taken from internet, and I believe it is microservices of Netflix. Okay, so they have so many microservices running in their system, and they are connected with each other with mesh, and how they are communicating, God knows. Okay, looking at this, it can be really difficult. Okay, and now imagine if something goes wrong somewhere, how do you know where it went wrong? How do you fix it? Will the system be able to heal itself? Okay, healing is one important criteria in our systems. Okay, when we talk about the cloud infrastructure. Okay, remember the word healing. Okay, your application should be able to heal by itself. So if you happen to develop such kind of a microservices, definitely you will be worried about it, maintaining it. Okay, and but thanks that we have a lot of tools available that can help us, okay, leverage certain things and manage this kind of mesh. Now, when we talk about pre-development things, okay, when I was talking about microservices, I have we write a code that needs to be built. Okay, in long earlier period we have AND scripts. Then with Java we have Maven, Gradle, and a lot of these scripts that can just build the binaries. Okay, or back to the make files in C++ world. Okay, I don't know people who are from that long period. Only I can see Shashank is here, who is from that world with me, who knows about make files and other things, where we build applications in a particular way. But building is not just, it's just a one part. After you build, you need an infrastructure to host that application. Okay, so you need, now the infrastructure is not part of it, it is part somewhere remotely, somewhere it's in US, UK, or any part of the world. Okay, so you need scripts that can build infrastructure for you, and you need a script that can do things repeatedly and that may not have a side effects. Okay, means if already built up things, it is not going to rebuild the certain things. It will know, yes, there are things available, I just need to diff it, I need to find what is not there and just add that things. Okay, so these are the tools, infrastructure as a code, that kind of that term came into existence, and we have a lot of such tools available, such as Puppet, Ansible, Terraform. Okay, choose whatever you like, whatever your team likes, and use that tools to build your infrastructures. Then we have building pipelines, where you can, as soon as your code is pushed into a repository, okay, it should run, it should build, create binary, it should be able to do unit test cases and all these things. So there are a lot of tools available, Jenkins, Bamboo, GitLab, and many more. Choose whatever you think is good for you. Now, yeah, I build applications. My applications require a particular version of Node or particular version of Java or .NET. Okay, and we deploy that applications on shared instances or virtual machines. It becomes difficult to manage the requirement, okay, for your software. And that's why the new thing that is available is containerization. You create a containers of your application that has everything required for an application to run. Okay, it has all the necessary softwares, it has all the necessary operating system things, compile, whatever you require. Every runtime that is required is available. You containerize it and you just run that container. Okay, there are various containers. One of the famous container that we have is Docker. Google also has something, I think pods or something like that. I don't remember, but Docker, I think, now in today's world, if you say we do not know Docker, then it's wrong. Go, guys, update yourself, update your skill set to understand Docker. Okay. Now you have these applications where you develop your applications in different containers, such as Dockers. Okay. Now you need to orchestrate them. Okay. You need to have a cluster, something called a cluster management. You need to scale your application. You need to add more nodes to your clusters and a lot of things. So how do you do that? Okay. So there are again tools available for that. Kubernetes is one tool. Docker Compose. ECS is what? It is an Amazon managed Elastic Container Service. EK is Amazon Elastic Kubernetes Service. Okay. I think we are running out of time, so let me try to cover it fast. So I was talking about when we deploy a lot of applications, right? Okay, how do my other applications are discovered by other applications, microservices? Okay, that is very, very critical. Okay, when my application is running, it should be, some other application should be able to find it so that it can communicate. So how it is done? There is something called a service discovery pattern. Okay. So in this service discovery pattern, when application starts, it goes and registers itself into a service called service discovery. Okay. There is a service registry where it goes and adds its instance. Then any other service who wants to communicate with that service will do a service lookup. Will say, okay, I want an account service. Give me the address of account service. Then the lookup service will return the address, whatever is the latest address, and then the client service can communicate with that service. Okay, Eureka is one of the examples. Eureka, again by Netflix. See a diagram where I have multiple services, service B, service C. Whenever, as soon as the services starts, they go and register into service registry. Okay, a service, another microservice who wants to talk, or a third-party client wants to talk, they go and do the lookup at the service registry, and then get that corresponding new IP address, and then go and talk to the load balancer to get that service, communicate with that service. So this particular pattern has a small drawback. In the sense, it has to make two calls. One has to find first do the lookup and then connect to that service. Then we have something called as an API gateways. Okay, very fantastic thing in today's world. So it's a gateway. It's a gateway. It's an entry point of your application. Your application, which is built up hundreds of microservices, you do not want all the microservices to expose publicly. You just want one gate where your application, where client can enter. Okay. The reason one gate, because it will help you to add securities, authentication, authorization, validation, lot of things on that. Okay. So API gateway is a pattern. Now, I know a lot of teams, they themselves write an API gateway. Okay. So to such teams, I would advise that please do not write your own API gateways. There are lots of API gateways available for your languages, whatever you want. Okay. So I just showed Zool is from again Netflix, then Spring Cloud API gateway. Express also has its own API gateway. You take that API gateway, you configure it. Okay, you define the routes, you define the tokens, validations, and everything like that by adding some rules. You can add filters and a lot of things on your API gateway. Do not build it. It's already available in the market. It's been tested and everything. So prefer, and they are open source and free. Okay, you can definitely use them. Now, how is API gateway? Okay, what API gateway does it? When a client calls it, first entry point is this API gateway, and it does do the logging, it does the validation of the token. It can also do the validation of token. It can do routing, it can do load balancing. Lot of things it can do. Okay, and that's why one of the fantastic patterns for an entry point of your application. Okay, what are the things it can do? As I mentioned, load balancing, routing. It can route your codes, means route your calls. It can do automatic mappings of your routes. Okay, when the new service starts, okay, if service wants to expose some public endpoints, you can automatically map them so that you don't have to manually add that routes into your API gateway. Okay, it can do URL rerouting. Okay, you can add predicates. Okay, if you can say, okay, I want just a get method on this route. Okay, I do not say your application calls your gateway, and then the gateway might transfer that call to the concerned microservice. Now that microservice says, okay, I'm going to expose one endpoint, and that has only get method. But someone is trying to send a post method to that microservice. Do you want your gateway to take that call and send it to the microservice, and then microservice reveals, no, I don't have a post method. I just have a get method. You don't want that to happen. So you can prevent that on the API gateway itself. You can define that this particular endpoint only supports a get method or a post method or get post, whatever things you want. You can add filters also. Okay, so a lot of things that you can add. One of the fantastic thing with API gateways. Please, guys, if you do not know about this, go and learn about API gateways. Very important for the development. Okay, for very important for your when you develop applications in microservice world. Now, run the business. What do you mean by run the business? Okay, my applications are starting and they might have problems. Okay, hundreds and thousands of microservices I have. We saw a mesh, right? We do not know how many microservices it has. Okay, something goes wrong. How do I find where did it go wrong? Will something went wrong will bring my entire application down? Okay, possible. If you do not know where it went wrong, you do not know how to write better loosely coupled applications. Okay, it can bring you down, and that's why in run the business as a software developer, we need to know what are the tools that we should have to identify such kind of problems in your system. Unfortunately, I cannot talk about all the tools. Okay, I can give you just a glance of what they. Okay, so let's see. Tools. Tell me any engineering field where we do not use tools. Okay, whether it is a mechanical or civil engineering, every engineering requires tools. Without tools, that engineering will not move ahead, will not progress, right? Similarly, software engineering also need tools. Without tools, without sophisticated tools, we may not be able to maintain our application, develop our application. And that's why I always tell my fellow developers that, guys, do not try to write. There are already available a lot of tools in the market. Just find it out and plug into your application. Okay, so remember, before you write anything, try to see if there is anything available, open source, free, that you can definitely use. Yeah, provided your organization allows you to use that, or ask your organization to buy that. But tools, very important. Okay, so tools can allow you to proactively find problems, monitor the systems. Okay, correct them, help you to correct things. A lot of things it can do. I will go a little bit fast now because we do not have time. Okay, so when we talked about microservices, when a request comes to your API gateway and it goes to first microservice, it does not terminate there. It calls that request go to a lot of other microservices in between, and it can flow to depth of the microservice and return it. Okay, now something can go wrong in somewhere else, or it might not go wrong, but it might take some time. Now you have to understand where it went wrong, which is the microservice that is creating the problem. Okay, that's where the term called as a distributed tracing. You should know how to do distributed tracing. You should know how to use the tools that will allow you to do the distributed tracing. Okay, you should know proper logging. You log your applications, and when you log your applications, you should be able to aggregate this log and find the data that is required for you. You should have health monitoring supports. You should have an APM things and a lot of things that matters. That's why using right tool matters to run your businesses. Okay, so distributed tracing, as I mentioned, right? If a request comes to your API gateway and goes to some of the microservices, you should be able to pinpoint which microservice took what time, what exactly time it ran, and how it behaved, all the things. Okay, look for open source distributed tracing. Okay, there are a lot of open tracing compliant applications. One of them is Sleuth and Zipkin. Okay, you can find this for Node applications also. It is for Java basically. Again, I think by Netflix, but yes, you can use them in your application. Definitely give a try. I might show a demo if we get enough time. Logging. Okay, when you log your applications, okay, you should be able to aggregate those logs. Okay, now some people use Sumo logs, Logstash, and a lot of things. And logging framework should be able also to generate alerts and other things. Okay, that will help you to find problems, monitor problems. Okay, Logstash is one of the examples that I'm trying to see. It is a free open source and it is built on a stack called ELK, Elasticsearch Log Stack and Kibana. Okay, Elasticsearch in the sense all your logging information is put into Elasticsearch memory where you can query it and get it. Kibana is a UI framework which allows you to go and look at the various add filters, search it. Okay, fantastic tools. Okay, if you want to see, go to elastic.co website, and they have huge tools for all development tools. I just named few of them, but you can find so many tools there. The APM tool, okay, there are a lot of APM tools already available in the market. Okay, New Relic is one of them. What does that do? Application program performance monitoring tools, APM. They monitor your nodes, CPUs, cluster CPU, memory, and everything they monitor. Okay, and they can generate alerts and other things for you. We have New Relic, we have Elastic APM also available. Elastic Observer, you can find on elastic.co file. Fantastic tools. Okay, definitely I wanted to give you the references on the slide, but remember that go to a site called elastic.co. You will find so many tools that will be helpful for you for your day-to-day applications. Okay, demo time. I don't think so we have time, and so we will directly jump into question answers. Okay, should I stop sharing the screen?
Yeah, you can stop sharing. Thank you, Pranay. And sorry, guys, we didn't got time to do the demo, but we can definitely take Q&A. So anyone has questions can unmute themselves and ask question. There is one question which is came on the chat that I can ask. So Pranay, it is how does system heal itself?
Okay, so there are some pattern, circuit breaker pattern. Okay, so learn about that circuit breaker pattern. So when the system, when we have a mesh of microservices and there's a flow of microservices, okay, system history circuit breaker pattern detects that a particular circuit has a problem, and if that problem is not removed, it will take down the entire circuit. Okay, so what it does is it proactively takes that particular thing from the out, so that new requests do not go to that particular path. They go to the path which is already available, which is fine. Okay, and ensures that people are the client requests are not failing, and at the same time it will generate some alerts for you, so that you can look into that what exactly happened and try to take some actions. Also, when the systems can find that, okay, my some instances have gone down and I require this minimum systems requirement of instances running, it will spawn up the new instances automatically. Okay, and that's how it can heal your system. Okay, definitely some systems cannot heal, they need operations, someone to go and operate on it. Okay, but when it can be healed properly, there are things, there are tools that are available, there are patterns that are available. Circuit breaking pattern, circuit break pattern. Remember that pattern, search about it, and try to use that in your microservice architecture.
Yeah, thank you.
Any more questions, guys? You can unmute and ask. Okay, thank you so much.
Either the presentation, it was enough for people to understand, or they did not understand anything. It was too bad that they don't have any questions. Whatever it is, I will take that.
No, I really enjoyed the presentation, and thank you so much, Pranay, for this session. And I hope everyone understood what you presented.
Yeah, unfortunately, time is always a constraint for us, right?
Yeah.
And that's the reason we cannot go. So this was initial part where I wanted to introduce you to the terms, introduce you to the tools kind of way where you can leverage tools. There are hundreds of tools available. I do not know all of them. I know only tools that I use. Okay, you can find own tools, share the tools with people. Okay, I learned the harder way. Okay, yeah, when we started doing things, I learned harder way, like Netflix. But Netflix was ideal for me. I used to watch their development things, so I know some of them, and I used to do it. For you guys, if you do not know, get familiar with the tools. Get familiar with the idea of being as a cloud developer rather than being a backend or a full stack developer. Okay, so that is my take. That's what I would like to tell you, that don't be just a full stack developer. Be a cloud developer.
Thank, thank you so much, Pranay, for the suggestion, and thank you for the session. And thank you all for being part of today's session. Just give me 5 more minutes. I'll just take just to give you heads about the upcoming events. So these are the upcoming events which coming up. These are tentative dates, but if anything changes, we'll keep posted on our channels. Now we also have a YouTube channel. So Swati will just put it on the chat, the YouTube channel link. So you can go to that channel link and you can click on bell icon to subscribe and get updated about all the new podcast or webinars we are doing. We also going to share this today's session also on the YouTube channel. So if anyone has joined late or missed, they can to the YouTube channel and watch it. Lastly, there is one more form by which you can join us. So that link also is also there on the chat. So you can fill up that form and you can join our community. And we really looking forward for many more people in this community and being contributors. Also, just last thing, there will be just poll which will come up right now for the feedback. So you can give quick feedback about the session, and if you have any suggestions, you can put it on the comments. And thank you so much for taking out time and taking this session. And we looking forward to see you all again. Thank you, guys.